Hello friends, welcome to SSP Math. Next problem of series solution is solve x into 1 minus x d2y by dx square minus 3x dy by dx minus y equal to 0. So if we compare this differential equation with this p0 of x d2y by dx square plus p1 of x dy by dx plus p2 of x into y equal to 0, then we will get here p0 of x is equal to x into 1 minus x, and this implies p0 of 0 equal to 0, and therefore x equal to 0 is singular point. Now we will get here x equal to 0 is singular point, so we have to check this point is a regular singular or not. For that we have to check that two conditions. First one is limit x tends to 0 x into p1 of x upon p0 of x. What is p1 of x? That is minus 3x upon p0 of x is x into 1 minus x. This x's get cancelled. So 3 into 0 upon 1 minus 0, so limit is 0 and 0 is finite. Okay, and second condition is limit x tends to 0 x square into p2 of x. p2 of x is minus 1 upon p0 of x, x into 1 minus x. So again this 1x get cancelled, x upon 1 minus x, so limit is 0. This is also finite, so both limits are finite, and therefore we can say that x equal to 0 is a regular singular point. And if x equal to 0 is regular singular point, then we have to assume solution of given differential equation is y is equal to summation of k varies from 0 to infinity a k into x raised to m plus k. And if we take y equal to this, then from that we have to write dy by dx also. So dy by dx is summation of k varies from 0 to infinity a k into m plus k x raised to m plus k minus 1, means only take derivative of this. Okay, and also we want d2y by dx square. So d2y by dx square is summation of k varies from 0 to infinity a k into m plus k, derivative of this, that is m plus k minus 1 into x to the power m plus k minus 2. So put all values in equation 1. Therefore given differential equation becomes here x into 1 minus x is, so multiply this x inside, so x minus x square into d2y by dx square, that is summation of k varies from 0 to infinity a k into m plus k minus 1 x to the power m plus k minus 2, then minus 3x into dy by dx summation of k varies from 0 to infinity. What is the value of dy by dx? ak m plus k x to the power m plus k minus 1, and minus y is summation of k varies from 0 to infinity a k into x raised to m plus k equal to 0. Okay, now here this x into this, separate this series, or x into this, that is summation of k varies from 0 to infinity a k into m plus k x to the power m plus k minus 2 into x, that is plus 1, so minus 1, minus x square into this, that is summation of k varies from 0 to infinity a k into m plus k minus 1 into x to the power m plus k here. Why? Because x square into this minus 2 plus 2 get cancel, minus 3 into x into this, that is summation of k varies from 0 to infinity a k into m plus k x to the power m plus k only, minus 1 plus 1 get cancelled, and minus last one is summation of k varies from 0 to infinity a k into x to the power m plus k equal to 0. Now observe this carefully, this series and this series. Here we can take x raised to m plus 1 k common, only this series is different, so write as it is. So this implies summation of k varies from 0 to infinity ak into m plus k, ak into m plus k into here m plus k minus 1, this one, into m plus k minus 1 into x to the power m plus k minus 1 as it is, minus, देखो यहाँ पर माइनस साइन है, here माइनस साइन है, here माइनस साइन है, we can take common, summation of k varies from 0 to infinity, here ak present है, here ak, so take ak common in bracket, right, remaining terms m plus k into m plus k minus 1 here minus 3 m plus k, but minus sign is common, so plus 3 into m plus k, here also minus sign common is, so plus 1 into x to the power m plus k equal to 0. This is equation 2. So this is equation 2. Now using equation 2 we have to find indicial equation. So for indicial equation, equate the coefficient of lowest degree term. Now what is lowest degree term? Here k starts from 0, so if we put k equal to 0, x की पावर देखो k इक्वल टू 0 पुट की तो यहाँ पर x रेस टू m माइनस 1 मिलेगा और यहाँ पर x रेस टू m मिलेगा, सो m इज ग्रेटर देन m माइनस 1, सो लोवेस्ट डिग्री टर्म कौन सी हो गई, x रेस टू m माइनस 1, so we have to equate the coefficient of x raised to m minus 1 to 0. And what is the coefficient of x raised to m minus 1 for k equal to 0? That is a0 m into m minus 1 equal to 0. But a0 is not equal to 0 and therefore m into m minus 1 equal to 0. So this equation is called as indicial equation. Now we have to find roots of this indicial equation. So roots are here m equal to 0 and m equal to 1. Means if we take suppose here m1 equal to 0 and m2 equal to 1, then m1 is less than m2 and m1 is not equal to m2, means m1 is less than m2, means which case is applicable here out of that three case 1 or 2 or 3. Here roots are distinct and differ by an integer, means if we take subtraction of m1 and m2, that is 1 minus 0 is 1 or 0 minus 1 is minus 1, and we know that 1 and minus 1 both are integers. So here this m1 and m2 differ by an integer, so we have to use third case, and using third case, what is the solution? Therefore solution is y is equal to c1 into y at m2 plus c2 into dabba y by dabba m at m1. मीन्स यहाँ पर देखो जो y की वैल्यू है, y की वैल्यू हमारा जो हाईएस्ट रूट होता है उसके लिए फाइंड करना है. लिसन केयरफुली, दिस इज वेरी इंपॉर्टेंट. वी हैव टू फाइंड द वैल्यू ऑफ y एट हाईएस्ट रूट and value of dabba y by dabba m at lowest root. Lowest value कौन सी m की 0. So dabba y by dabba m we have to find for m1 equal to 0 और m equal to 0. अब देखो y के लिए हमें क्या चाहिए, recurrence relation. Okay, and how we find recurrence relation? For recurrence relation we have to equate coefficient of x raised to m plus k with 0. Now observe this step carefully. Here we want x raised to m plus k. We have to equate coefficient of x raised to m plus k from equation 2 with 0. So when we get here x raised to m plus k, if we put k equal to k plus 1, ये जो k इस k के जगह पर यदि मैंने k plus 1 पुट किया तो k plus 1 minus 1 कैंसिल होके यहाँ पर m plus k रहेगा. एंड वी वांट कोएफिशिएंट ऑफ x रेस टू m plus k, मीन्स यहाँ पर भी हमें क्या पुट करना है, k इक्वल टू k plus 1. सो क्या आएगा, ak plus 1 इंटू m plus k plus 1 इंटू m plus k plus 1 minus 1 get cancelled. So this is the coefficient of x raised to m plus k from this series, minus from this is x raised to m plus k, its coefficient is ak into m plus k into m plus k minus 1 plus 3 into m plus k plus 1 equate with 0. Now try to simplify this and try to find recurrence relation here. So recurrence relation, how we find? ak plus 1 into m plus k plus 1 into m plus k is equal to ak into, here observe, m plus k we can take common, and if you take this m plus k common, bracket में क्या रहेगा? m plus k minus 1 plus 3 plus 1, last one. Okay, so after simplification, what is this? This is ak into m plus k, here m plus k minus 1 plus 3 is 2 and plus 1 कैन बी रिटर्न है. देखो इस m प्लस के को यदि मैंने एक ब्रैकेट में लिया और इसके अंदर मल्टीप्लाई किया तो ये क्या मिलेगा? ए के इंटू एम प्लस के इंटू एम प्लस के होल स्क्वायर प्लस 2 टाइम्स m plus k plus 1. So what is this? This is ak into m plus k plus 1 bracket square. So ak plus 1 into this is equal to this, and therefore ak plus 1 is equal to m plus k plus 1 bracket square upon m plus k plus 1 into m plus k ak is equal to this. M plus k plus 1 get cancelled, m plus k plus 1 upon m plus k into ak. So we will get here ak plus 1 is equal to m plus k plus 1 upon, means recurrence relation is ak plus 1 is equal to m plus k plus 1 upon m plus k into ak. This is the recurrence relation. Using this we have to find constant by taking k equal to 0. So if you take k equal to 0 here, then we will get a1 is equal to m plus 1 upon m into a0. Okay, then if we take k equal to 1, then we will get a2 is equal to k equal to 1 के लिए m plus 2 upon m plus 1 into a1 is equal to m plus 2 upon m plus 1 into a1 की वैल्यू क्या है? m plus 1 upon m into a0. So this m plus 1 get cancelled, that is m plus 2 upon m into a0. So this is the value of a2 and so on. Okay, now so this is a1 a2. So we have to find now solution. So what is solution? Solution is y is equal to summation of k varies from 0 to infinity ak into x raised to m plus k. So you can take x raised to m outside into series रहेगी k varies from 0 to infinity ak into x raised to k, can be written as x raised to m into a0 plus a1x plus a2x square plus so on is equal to a0 x to the power m into a0 plus a1. Now what is the value of a1 here? A1 is m plus 1 upon m into a0. So a1 is m plus 1 upon m into a0 x plus a2 आया था m plus 2 upon m into a0 x square plus so on. Okay, so from this we can take a0 common. So if we take a0 common, then y is equal to a0 into x raised to m, ब्रैकेट में क्या रहेगा? 1 plus here m plus 1 upon m into x plus m plus 2 upon m into x square plus so on. This is equation 3 say. Okay, so this is the value of y. Now what we want for solution? We want we know here, or we get here two values of m. First one is m equal to 0 and second one is m equal to 1. So we have to find the value of y at m2 equal to 1 maximum के लिए, and value of dabba y by dabba m at m1 equal to 0. So if you put here m2 equal to 1, then we will get a0x into bracket 1 plus 2x, okay, plus here 1 plus 2 is 3 upon x, means 3x square plus so on. So this is the value of y at m2 equal to 1. Next one, we have to find dA by y by dA by m. So differentiate equation 3 with respect to m. Therefore dA by y by dA by m. Before to find here dA by y by dA by m, but we have to find dA by y by dA by m at m equal to 0, and if you put m equal to 0 here, then we get infinity. So first we have to put here a0 is equal to b0 into m, means a जो m है ये m हमें कैंसल करना पड़ेगा बिकॉज वहाँ पर 0 होता है. सो ये स्टेप याद रखो, जो भी होगा पॉइंट उसके लिए. फॉर एग्जांपल आपको m इक्वल टू 2 पुट करना है तो m माइनस 2 आएगा. ओके, सो a0 इक्वल टू b0 इंटू m माइनस 2 ऐसा पुट करने का. यहाँ पर m है तो put a0 equal to b0 into m and rewrite again y. So y, how we write here, a0 is b0 x raised to m, and इस m ने मैं अंदर मल्टीप्लाई करता हूँ तो m into 1 m आएगा, प्लस दिस m get cancel, m plus 1 into x, plus again m get cancel, m plus 2 into x square plus so on. Now we have to take derivative of this y, that is dA by y by dA by m is equal to, for derivative we have to use here u into v rule because x raised to m here and in bracket also m present है. So b0 keep as it is, derivative of x raised to m with respect to m is x raised to m into log x into this bracket as it is, that is m plus 1 into x plus m plus 2 into x square plus so on, plus b0 into x to the power m as it is into derivative of this bracket, derivative of m is 1 plus derivative of m plus 1, m का derivative 1 आएगा, 1 का derivative 0 आएगा, x plus derivative of m plus 2 is also 1, x square plus so on. Okay, what we want dA by y by dA by m at m1, and what is m1? m1 is 0, means put m equal to 0 here. So solution is b0 x raised to 0, that is 1 into log x into bracket 0 plus x plus 2x square plus so on, plus b0 into x raised to 0 is again 1 plus x square plus so on. So this is the dA by y by dA by m at m equal to 0, and therefore final solution is y is equal to c1 into y at m2 equal to 1 plus c2 into dA by y by dA by m at m1 equal to 0. So how we write here final answer, c1 into a0x 1 plus 2x plus 3x square plus so on, that is this, plus c2 into write this value here, that is dA by y by dA by m at m1 equal to 0. Okay, so this is the one problem on case number 3. Now with the help of this problem and last video's problem, you solve two problems. First one is this problem, that is solve x into 1 minus x d2y by dx, का same problem है, minus 1 plus 3x into dy by dx minus y equal to 0. This problem is on case number 3a. You try this. And next problem is on case number 2, that is this. So you try this problem also at home, that is solve x into d2y by dx square plus dy by dx minus y equal to 0. So this problem is on case 2a. Okay, so try these two problems at home. If you have any doubt, then you can ask on WhatsApp or in comment section. Thank you. Thanks for watching. If you really like our videos, then subscribe the channel. Thanks.